Hey everybody, and welcome to the screencast on not the sine law, but rather what's called the cosine law. Okay, so a couple of days ago, you went through and thought about a survey and or were shown these particular images and were asked, which of these triangles could the sine law be used on? Okay, so recall what the sine law stated was that if you have any particular angle and opposing or corresponding side, its ratio is equal to some other sine of an angle and its corresponding side length. That is as a ratio. So take a moment, actually, if you haven't gone through this process yet in class or with somebody, pause the video and think about it. Which of these does the sine law apply to? Now that you've thought about it, let's take a quick look here at the responses and then we'll quickly see why it does or does not apply. So the first one, sine law. Second one, sine law does not apply. Third scenario, does not apply. And lastly, it does. So let's look at one that does and one that does not and try to figure out why it shouldn't. Okay? So on the basis of your classmates' results, or results that were collected from the survey, here's what people were saying. Okay? So the majority of people were looking at the sine law as being a tool that could be used. So that's good news. Okay? So that means that almost three quarters of the group survey saw as a sine law question. And the quickest way to tell is by looking for this X pattern. So the X pattern specifies that we can write sine of 79 in relation to X as sine of 37 relates to 13 centimeters. So you can write a sine law relationship for that particular triangle. Whereas with this one, let's see what your peers thought about it. Okay, so most were thinking that you cannot use trig ratios, and that means sine, cos, or tan, because there's no right angle. Okay. So you can see high percentage looking at using something other than the sine law. And the reason for that is as such. Okay. So we do not know any of the angles. So therefore, we cannot write a sine law equation. In fact, if you try to do it, if you take the sine of A, which we don't know, that relates to its opposing side length of 28. Well, if we pair that off with, say, the sine of C, which relates to 22 meters, you can see we have two unknown angles. There's just no way that we're going to be able to solve for either one of them. Okay, so that is the essence to it. If you can see, right, so 32 does not match off with any side length, and we have no remaining angles, hence the reason that it's no to the sine law. Okay. Whereas with the last one, you can see with this triangle, let me increase the size of this here a little bit. So this is 102, this is 68, this is unknown, okay, and we have one side length. So the unknown and the side length could very well be paired off with 102 as an angle size and say X, because you can find this particular angle here, right? It's just the difference between 180 and the sum of the two angles you already have. So this one is definitely a sine law question. Okay. So now that you've sorted it out, what is and what isn't, just what is it that we're going to do with triangles that can't use the sine law? Well, we're going to use what's called the cosine law. Okay. So here are two scenarios. These two scenarios We have triple S and SAS. Under these situations, you can use the cosine law. So here's what it means. So as far as SAS is concerned, it means side, angle, side, in that particular fashion. Okay. Sometimes the A is referred to as the contained angle. Contained angle. So SAS. Okay, so the angle must be contained. Whereas side, 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 you have all three sides. Okay, so triple S. And in these cases with triple S, you can get any angle you want. And over here, you can calculate the length of the side that is across from the given angle. Okay, this is called cosine law. Now, with the sine law and with SOHCAHTOA, we had equations. The same thing applies here for the cosine law. So, very quickly, what I would like you to do is to think about the question and pause the video and write something down. So, in the left-hand triangle, I want you to write down whatever relationship you already know about those three side lengths. Okay, so you might have recalled from the past that C is the longest side. That's your hypotenuse in a right angled triangle. So in this relationship, the sides, we can relate them as C squared equals A squared plus B squared. That's what has been called or is called the Pythagorean relationship, or some call the relationship a theorem. Okay. Well, the triangles we're looking at aren't right triangles, but rather they're non-right. So how can we apply an old theory to something that's new and different? Well, think about this. So let's say that we manipulate the current triangle. Okay, so we have a mirror image of this one over here. So I've taken this triangle right here, and I've basically copied its image over to here. Okay. Then what we're doing is we're grabbing a hold of this vertex right here. Right? We're going to grab this point right here. And what we're doing is we're taking that vertex and we're dragging side B. Okay, we're dragging it out over to C, thereby creating a non-right triangle. Okay. Now study the impact of that. What does that dragging action actually do to some of the attributes of the triangle? Well, the length of B has increased, right? So B has increased in terms of its length. What else changes? Well, look at side A, okay? So over here, we have it as this length. But now that we've pulled out angle C, you can see that A has decreased. Or sorry, has increased. My apologies. It's now the hypotenuse of a smaller right triangle. Let's try that again. So A has increased in size. It's something else has happened too. Take a look at angle C. Angle C, right here, has decreased in length, okay? Or in size, I should say. So it's gotten smaller. So because of all of these changes, what's happening now is we cannot further or no longer use the existing Pythagorean relationship that we had for the triangle here on the left. It doesn't work. But we can, and through an algebraic proof, okay, we can show the following relationship is true. Okay? So in this case, c squared equals a squared plus b squared with a correctional factor, okay? So we're going to subtract away some correctional quantity, okay? It's going to allow us to use the Pythagorean relationship. That factor, that quantity, it has to take into account the fact that b has increased, the angle c has decreased, and that a has increased in size. So that particular factor is what we call the product of 2ab multiplied by the cosine of angle C. So I'm just going to pause here for a sec. We've got a visitor at the door.
Sorry, bud. I just need to borrow a key for a second. I just locked myself out.
Oh, yeah, for sure.
Sorry.
No problem.
I will be right back.
All right, guys,
Sorry
back at it.
about that.
No problem. Mr. Beckett making a guest cameo appearance in our video today. So the factor, or rather the quantity, I should say, that's going to correct the Pythagorean relationship is 2ab multiplied by the cosine of angle C. And this is the cosine law. That's exactly what this thing is here. Okay, so FYI, cosine law, new formula. You can use it in non-right triangles, specifically when you see these conditions, triple S and SAS. All right, so what we can do now is you can close the video off here. You've got your background, or you can continue playing on to go through this example. Better yet, if you pause it and attempt the example, then you can race through to a solution and see if you've got it or not. Okay? So here's an example involving SAS. So we have a triangle with these particular measurements. We're being asked to solve the triangle. So just taking a look here, we should probably sketch this thing out. You can see that A is 111. So with a 111 angle relationship, that means that we're going to have an obtuse angle of 111 degrees. That's angle A. We don't know what side A is, so we'll leave that blank, but B and C are given as measurements. So side B, which is over here, across from angle B is 74, and then angle C here, with side C being across from it, and that would be equal to 29. So according to the cosine law, and we have an SAS situation here, so side angle side, we can write the following. The square of the side we want is the sum of the squares of the sides we have. Take away this particular correctional quantity. In this case, it's going to be 2bc. So 2 times b times c multiplied by the cosine of the angle we have, which is angle A. Okay. So all we need to do now is do a substitution. So in go the values. So 74 squared plus 29 squared. You'll notice that we'll have some large numbers here. That's 2 by 74 multiplied by 29 multiplied by the cosine of 111 degrees. Now, ensuring that your calculator is in degree mode, let's go ahead and key this in. So watch closely as I process the calculation. I try to do it in as few steps as I need to, so I'm not writing down a lot of different numbers and rounding along the way. So what we can do is we can do the squares first. So, and write those down. So 74 squared is 5476. And then 29 squared happens to be 841. Minus, okay, let's open up a bracket here. And let's do all of the bracket. So I like to start with the cosine first. So I'm going to find the cosine of 111 degrees. Comes out as a negative number. That's new and different, and that comes up in the grade 12 course. Multiply that by the lengths we have. So 29 times 74, and then double that response, and I got negative 1538 roughly. So that's negative 1538. All right. Okay. So now we just have to add everything up. Be careful here though, double negative. That means we're going to add 1538 to the remaining numbers. So we're going to add 5476, 841, and 1538, and we'll see what that gives us. And I like where this is going. We're going to get a rather large sum, which is good because this side is the longest side. So this is good news for us. So grab that scientific calculator. Let's add 1538 to 841 to 5476. Gives me 7855. And last but not least, remember that's the value of a squared. So a must be the square root of 7855. So that means that a, to the nearest unit, is going to be 89. So 89 units of length. So just double checking that diagram again. This is really good news. So across from 111, we've got 89, okay, which is longer than the next longest side, which is 74, which would have to be across from a smaller angle. Okay? So that's an SAS situation of the cosine law. And next time we meet again, either in cyberspace with our video or right in the classroom, we'll look at the triple S situation.